So in this video, what I'm going to do is I'm going to explain how you determine if a bond is polar or nonpolar, and if a molecule is polar or nonpolar. And so the first thing that we actually have to talk about in order to talk about bond polarity, we have to talk about this term electronegativity. Okay, so electronegativity is an atom's attraction for electrons. So remember, when we are talking about, for example, covalent bonds, what we're saying is that electrons are going to be shared. And so what we need to consider is, well, that sharing might not necessarily be even. So for example, if I give you, I don't know, O and F, okay? Well, we draw a line between these two atoms. That doesn't necessarily mean that they're going to be sharing the electrons equally, and so what we have to do is compare their electronegativities. So as you move across the periodic table, your electronegativity increases, but as you move down the periodic table, your electronegativity decreases. So if you compare oxygen versus fluorine, fluorine is more electronegative than oxygen, and so the way that we're going to represent this difference is we're going to draw an arrow showing that fluorine is hogging the electrons. Now, a couple of terms. We say that this bond here, because there is a difference in electronegativity, we say that the bond is going to be polar because there is a difference in electronegativity. So if you actually look at your notes, one of the ideas that I've introduced was actually quantitatively comparing differences in electronegativity. So if the difference in electronegativity is between 0 and 0.4, so there's a very little difference in electronegativities between the two atoms, then we say that the bond is nonpolar. If it's between 0.4 and 1.8, then we say that it is polar, which is the case, for example, for right here. And then if it's more than 1.8, at that point we no longer have sharing of electrons. Instead, because one of the atoms is hogging the electron so much, it gets to the point at which that electron will just be donated rather than being shared. So here, we're not actually going to be calculating values when you have a quiz or you have a test, but that's to show you that you kind of have a continuum. If the electrons are being shared pretty much equally because the electronegativities are very similar, then the bond is going to be nonpolar. If they're not sharing it equally, then it's polar, and if they're not sharing it so severely that electrons are donated, then the bond is ionic. So here the bond is going to be polar, okay? And then when we're talking about the molecule, I'm going to just come up with an example. For example, if I had OF2, which would look like this, okay? We know that fluorine is more electronegative than oxygen. And so when I draw my dipoles, which represent the difference in charge, because remember, fluorine is grabbing those electrons towards it, so the dipole you draw like this and like this. Okay? For a molecule to be nonpolar, these need to cancel. So if you can imagine kind of a tug of war, if one person's pulling this way and one person's pulling this way, this molecule would move, and therefore it's going to be a polar molecule because these dipoles do not cancel out. The only way for it to be nonpolar, for it not to move, would be if you had someone else pulling that way, which we actually do not have, so I'm going to get rid of that. So the molecule itself is also going to be polar. Okay, so let's actually look at an example. I'm going to get rid of everything. Let's look at a couple of examples that you guys had in your notes. So for the first example, I'm going to give you HF. Now, HF, if I draw HF, remember it needs 8 valence electrons. Okay. And so they're going to be 6 on fluorine. Remember, hydrogen only needs 2. So that's going to be my drawing for HF. Now, the only way for the electronegativity difference to be small enough for your bonds to be considered nonpolar for this class is if you have the same atom. So if this were F and F, then the difference in electronegativity would be 0, and so the bond would be nonpolar. But here, because you have two different atoms, the bond is going to be polar. Okay? Notice since fluorine is more electronegative than hydrogen, this is what you're going to have. That's going to be your dipole. So your molecule itself, because that dipole doesn't cancel out, that molecule is also going to be polar. Okay? If you look at the next problem, I give you Cl2. Now for Cl2, if I draw this out, you remember you want 14 valence electrons. This is what it looks like. So your first reaction should be, wait. The bond itself is nonpolar because there's no difference in electronegativities because they're pulling with the same amount of force. So this is nonpolar. Notice there is no net dipole. You don't have a dipole pulling one way or another, and so therefore the molecule itself is also nonpolar. Okay, let's look at one last one. If I have CBr4, okay, 4 valence electrons for carbon, 28 from the bromine, so that's a total of 32. So this is actually going to look like this. Remember to draw it properly with a tetrahedral shape. So the bond, because I've got carbon and bromine, I'm going to assume that it's going to be polar. Since bromine is more electronegative than carbon is, I'm going to assume that the dipoles look like that. Now this one's kind of hard to see, but imagine someone's pulling down, down, and down that way, and someone else is pulling up that way. Notice horizontally, someone's pulling to the left, someone's pulling to the right, someone's pulling up, someone's pulling down. Therefore, the dipoles cancel, and therefore your molecule is going to be nonpolar. Okay, so just as a really quick review, a couple of things. The first being, sorry about that, the first being a bond. Now, you can have 2 different types of bonds, but for the purpose of this, we're just going to be talking about nonpolar and polar. If your bond is nonpolar, what that means is that the difference in electronegativities is practically 0. If there's a difference in electronegativities, then it's going to be polar, and we're not going to look at ionic because ionic, you don't actually have any sharing of electrons. Instead, they're donated, and so we're not going to consider ionic, but that's the extreme where they're sharing so unequally that in fact they're donated. For a molecule, it is nonpolar if your dipoles cancel out. It is going to be polar if your dipoles do not cancel. And that's it.